Imagine you are at a supermarket pushing a shopping trolley. If the trolley is empty and you give it a hard push, it zooms away from you very quickly. But if you fill that same trolley with heavy grocery, the same push will barely make it move. You have to lean into it like you are trying to move a wall. So, same force, completely different results. Why? Because the more mass an object has, the harder it is to change its speed. I am Dr. Zef. I hold a PhD degree and I am UK certified teacher. But more importantly, I am here to teach you science the way I wish I had been taught the first time. The super easy way. No confusion, no boring lectures. Just science made simple. So let's dive in. Think about kicking a football. If you give it a tiny, gentle tap, it rolls slowly. However, if you put all your strength into a massive kick, the ball flies away much faster. This is the basic rule of the universe. The change in an object's motion depends on both how much force you use and how heavy the object is. Newton figured this out in the 1600s and gave us the cleanest formula in all of the physics. Force equals mass times acceleration. F is equal to ma. F is force, the push or the pull measured in newtons. M is mass, which is how much stuff the object has. It is measured in kilograms. And A is the acceleration, how quickly the speed changes meters per second squared. These three things are locked together. Change one, and the others have to respond. It's like a seesaw that never lies. Here's where it gets interesting. In the real world, forces don't come alone. They show up in pairs, in groups, pulling in different directions, like a tug of war happening inside every object, every moment. The one that matters is called the resultant force, the winner of that tug of war. So if I push a 10 kilogram box with 50 newtons force to the right, but there's 30 newton of friction pushing back to the left, the resultant force is 20 newtons to the right. Rearrange our actual formula and our formula becomes A is equal to F divided by M. Plug in the values, that's 20 divided by 10, which is equal to 2. So the box accelerates at 2 meters per second squared. Every single second that force is applied, the box gets 2 meters per second faster. That's Newton's second law in action, where the acceleration always happens in the exact same direction as the resultant force. If you double the force on a toy car, it speeds up twice as fast. But if you double the car's mass instead, its speed is reduced by half. The physical rule is simple. Acceleration is directly proportional to the force you apply, but inversely proportional to the mass of the object. Let's talk about something more exciting and more real. There is a car called the aerial atom. No doors, no roof, no windshield. It looks like someone forgot to finish building it. But here's the catch. By stripping away all that weight, all that mass, the engineers basically gave Newton's second law a cheat code because acceleration equals force divided by mass. If you cut the mass in half, you double the acceleration for the same engine. That's not magic, that's just maths. Okay, this one breaks people's brains. Drop a lead brick and a feather at the same time in a vacuum means no air is present. Both objects will land at exactly the same moment. How? The brick is way heavier. Shouldn't gravity pull it down faster? Here is the thing, gravity does pull the brick harder. It has more mass, so it feels more gravitational force. But that same extra mass also makes it harder to accelerate. More force, more resistance. They cancel each other out perfectly every time for every object. The ratio of weight to mass is always 9.8. It's a constant. So every object, regardless of size, falls at 9.8 meters per second squared. That's the acceleration due to gravity. Newton figured this out, Galileo proved it, and it's still wild every time. If Newton's third law is still a mystery to you, don't worry, that's next. Like and subscribe so you don't miss it. And I'll see you in the next one. Bye.